Today I wanted to do something which I didn't do for a long time. I want to do just a happy little video about bicep again. I didn't do a bicep video in a long time, so I thought why not? So the content will be virtual network deployment with bicep. So this is something as I recognize when I look at customer projects or stuff my colleagues do. I recognize that this often is kind of not taking into consideration that Bicep got some updates, some interesting ones. And I thought, why not make a video about, hey, let's deploy a VNet with some subnets, just a plain VNet with subnets, talk about some details of the VNet, maybe deploy some resources into it, see how we can debug a VNet, stuff like that. So this is going to be today. It could get a little bit longer, this video. I will create chapters because I will start from plain, doing resource group deployment and all of that. You can skip chapters if you feel familiar with the stuff, like how Bicep works and so on. But in this video, I will start like with not zero knowledge about Bicep. You should know what Bicep is in principle and, should be able to read the syntax. If not, go ahead, check my other videos in this series maybe. And yeah, with that, let's try to do it. Okay, so as I said, I will start at nearly zero. I have a README here. All the source code will be in the description. And let's start with a new file, as always, called main.bicep. So if you're not familiar, you should have an extension in Visual Studio Code. That's what I'm using installed, which is the Bicep extension by Microsoft. And this helps you a lot in writing this. So let's start. So what I want to do is my main bicep will be in the subscription scope. Why is that? It will be there so that I can deploy the resource group and then call the deployment for the VNet in the resource group directly. So that's what I'm going to do. So what I'm going to do is create a resource with the variable name this, and it should be a resource group. Let's come. There it is. Newest version equals required properties. Let's go codingfreaks sample. And location should be coming as a parameter. Let's do that. Param location, it's always good to have that, is a string. And then we pass it in. So this is the Azure region where to deploy to. Don't know if this is good English. Let's do some tags or one tag to tell my team, well, actually, this is a demo resource so that this is tagged. And okay, here we go. And I already prepped my Azure. This is my LZDD test. This is my landing zone. So this is my subscription I want to deploy to. Nothing is here yet. And I will do that in that subscription. So my AZ context for my AZ tooling is already on that subscription, should work. And now I could do new AZ deployment, blah, blah, blah. I'm not going to do that. First, I will create another file, which is called main bicep param, or let's say demo bicep param. Let's say it this way. So this is kind of my stage parameter file. So what I'm doing is, hey, you should be referenced or referencing this main bicep file. Look up what this main bicep file needs for parameters to come in. Here we go. And then I just give him this string. So here, I'm usually deploying West Europe. I'm resided in Germany, as you can tell by my accent probably, but I'm going to West Europe, which is in the vicinity of Amsterdam, or let's say Netherlands at least, which is the next main region, which has direct access to the undersea cable backbone, if you will. So I'm not going to do the overland stuff. And this is why I'm going to decide West Europe instead of Germany. I don't like Germany. No, I mean not the country necessarily, but the region. Anyways, so I'm going to deploy here. So what I usually did often was this, because it's kind of better readable. Don't do that. There are resources which don't like this and like it to be this way, and this works for all the resources. So if you have like East US or something like that, you should probably switch to the East US in one word location syntax, because some of the resource or modules of Microsoft don't like the human readable form. Okay, good. So almost done. The next thing I want to do is I create a new file and call it deploy ps1. So it's my PowerShell, which actually is going to be the file I always called in order to deploy this stuff. So what I'm going to do, first of all, I will add my command, which is New-AzDeployment. And then if I'm doing this general deployment, not saying resource group and so on, what actually happens, I need to always define a name. This is my deploy cf sample, so that I can distinguish this deployment from other deployments. Then the location here needs again to be something, and I'm going to call it West Europe here. So this is always confuses people. This is the first time they say, well, why do I need to pass in a location parameter to my New-AzDeployment thingy? So let's take this apart. Always in PowerShell, if you see a new verb, it means that you create something. So, and the something is always specified by whatever comes after the new, after the verb. So the this is what you create. So if this says New-AzDeployment, what you actually do is you create a resource in Azure. The type of that resource will be a deployment. So actually, a lot of people think, well, this command just executes something. Not exactly. It creates something called a deployment in Azure, which then tells the Azure Resource Manager what and how to deploy in Azure. And the good thing is the deployment will remain in Azure. So if something goes wrong in a way that you are not the culprit because you did something, but let's say, as it happens, that Azure is doing, I wanted to say something which is not good for the algo. So Azure failed at some point because some of the newest resources have bugs, which happens a lot. So you need to get in contact with the support team at Microsoft. So in that case, it's good, as we'll see in a second, it's good if you have something to refer to for the support, to tell them, hey, look, this is my deployment ID, look it up for me, because that fails and it should not fail. Tell me why it fails. So we will look up at this in a second. So location, West Europe. Okay, cool. So next thing you need to specify is a template file. Which in our scenario, come on, if I can type, is the main.bicep. This is the template file. And then let's give it a template parameter file, which is the main, the demo bicepparam file. And then what we could pass in is, hey, actually, it would be good if we could have a what-if deployment, but how do we control that? Well, easy. Let's add a parameter block here, and let's give it the type of switch. It's a switch parameter. That's how you do it in PowerShell. Let's call it what-if, because that's a convention for the what-if script, and just pass our what-if down to the what-if of this command. It's just passing it through the parameter. So what I can do now is I can take my bicep file with the demo file, and then I can just execute deploy ps1 with what if and see what happens. So it's running. So what the what if says, it's not actually performing the deployment in Bicep. It is looking into Azure, looks up what is actually deployed. In that case, it looks for the resource group with that name in this subscription. And this subscription being the one that I just chose to be connected to. So it always depends on your current AZ context. So this is the subscription. And he tells me, well, actually, this is what I would create if you execute me without what if. This format is usually a lot too chatty. So what you can do is what if result format, I think, and this is going to be, I I usually, so here Visual Studio Code is not giving me the thing. So here what you can do is New-AzDeployment, what if result format, and then you can, yeah, here you go, resource ID only. This is what I searched. So when Visual Studio is not giving you the right stuff, the extension, just go out and take it from the terminal itself, then you get the tab replacement. So let's execute it one more time. And this time the output format should be way better and show us just one entry for the resource group without the details. We're not interested in that. If you're interested in that, you could take this whatif result format as a parameter and so on. So you can do a lot of automation with that. So here we go. This is the sample thing. So because I want you guys to be able to use my code, maybe you don't want to name it this way. So what we could do in order to be nice guys, param, this is project name, let's call it this way, is a string, and then we just concatenate the string this way. And let's be cautious because it's always good to have the same casing. So let's take whatever project name it is, make a lowercase description, and then this is the name of the project. Good description, like it. And then what I usually do, I add something more, and this is stage. And stage is not known. Let's go and add this parameter, stage string, and that would be the name of the stage. That's what I do. And then my bicepparam says I'm not happy because your main bicep requires two more params which are not defined here. So that's because those params have no default value or a string question mark, which means they are not nullable. They need to be provided. That's why he knows you need to define that. So let's say my is CF and this is demo. Okay, this is now what I have. Good. Let's do a new whatif deployment first to see now actually what is the new resource group. Is it correctly deployed here? Let's see. Or let's say it's a string building correct. Let's see. So now it's CF demo. He built it correctly. And maybe, you know what? Project is project name. So here we go. And let's actually now execute this bicep. So this should be pretty quick. And now we should have a resource group. And from that moment on, we can switch over to create some resources, which is the VNET. Let's wait. Oh, it's already succeeded. I didn't mention. So it succeeded. And let's look if we now have, and this is, you know, Azure Portal lying in the first refresh because it's caching. But anyways, here's my resource group. That's exactly what I needed. Let's refresh. So we scope to the resource groups. Here we go. It has the two tags deployed, project CF, like this was my project name, purpose is demo. And we have no resources deployed. That's great. And the name is RGCF demo. Okay, cool. We have an empty resource group. So let's switch over now, or switch gears, and now talk about the resources. So what you cannot do, you cannot add like, I don't know, virtual networks here. You cannot do that because it will fail, because it said you are on the scope subscription and you cannot deploy resources like VNETs directly into subscriptions like here. You cannot do that. So the only thing we can deploy at this level is whatever can be deployed into a subscription. So that's not how it works. So in this scenario, what you actually need, you need a second file. And I usually call that my resources.bicep. Here we go. And my resources bicep has a new target scope, which is a resource group. So now what you can do in your main bicep, you can say, well, actually, I have a module, aka another file, which is the variable for it should be resources, and then it should be this file, and then required properties. So, and the one required property here is the scope. And the scope is just the group I deployed here. So let's talk about this. So first of all, from this moment on, Bicep knows that this deployment, this thingy here, this one, is the second, and this one is the first he needs to do, because this references this deployment. So that's the first thing. Bicep will wait with this deployment until this deployment is succeeded. And only then it will do whatever this module says. Second thing, the module needs a scope. It needs to know where to deploy. And this scope needs to be a resource group. Why? Because we said so. This file says I need to be called in a scope which is a resource group. Which resource group? I don't care. Just give me my resource group. So we do that by just pass in this the variable name of that resource deployment, which in Bicep means either it just created this resource group or it ensured that this resource group exists and then passes the reference over to this module. That's how it works in principle. Okay, what I also want to do is I want to keep those parameters in my file. So let's do that. So I still want to have naming conventions going on, so I want the same parameters. That means now that this says, no, you can't do that. You need the parameters now, and I can simply pass them through. Because in my deploy script here, where I defined where to take the parameters from, I can only tell it one template file, not first deploy this and then the other one. This would be a mess. So that means this deployment calls the main bicep, passes in the parameters. So if the main bicep then calls the resources, it needs to pass through the parameters so that if I need them, so that I know which location are my resources in. So here we go. This yellow thingy means you have a parameter which you actually do not use. Okay, so now we're ready to go, and we could define our VNet. Before I do that, let me show you, because I told you when we talked about this deployment, let me show you this new resource that you created. So if you're here in the resource group, what you can do is, you see there are no deployments on the resource group, but there are deployments on the subscription level. So let's go to the subscription because we deployed the first deployment to the subscription. So what we can now see here is, where's that? Settings, deployments. Here you go, deployments. And if you look here, you can see a deployment with the name deploy CF sample, which this is the deployment, and you probably saw the screen when you clicked around in the Azure portal. So your deployment is complete, nice. So we have a deployment name, which happens to be the name that we gave it. And then to a certain subscription started at this time, correct. And it has a correlation ID and it has details because it deployed one resource being a resource group, and we get operation details, which tell us what we can tell to the Microsoft support if something failed. Okay, good. So now the interesting thing is, if you deploy a resource and define a name, it will come up here. But let me show you something. If you now deploy this module, which I can do, right? Let's do the deploy and let's do it with what if. It should tell us that nothing happens. So he has some warnings because we still have those unused parameters in that bicep file for the resources, but never mind. This should tell us that nothing changes. Let's see. Okay, so he says that he has to deploy this thing, but actually because this already exists, he will do nothing. So let's execute this and watch what happened. So again, the warnings, never mind. Warnings is just because, again, we have here some parameters that we don't use. Those warnings appear here again. And it succeeded again. It was an incremental update, which is a default on Bicep, which means he will not destroy any resources if I would remove them here from the stuff. But anyways, here it is. And let's see what happened now to my deployment. I'm not even sure. So this is now 14.14. This is the old one. Let's see if he refreshes here. Yeah, it's now 14.46. So this is a new one. And it has now this problem. So the resource group itself was deployed. And now he says, well, I have a deployment which is called resources dash and then a GUID. So what's going on? What's going on is that my module here was named resources. So what Bicep by default does is if you don't name your module, if you don't give it a name, it will take the name of the variable and add a GUID, which I don't like. So what I will actually do is I will give it this name. There was a time in Bicep where this parameter was mandatory because they did not auto-generate this name. And I liked it a lot more because I don't like this stuff. So now what we will do, we will go ahead here and delete the deployment on the subscription. Let me go there. Deployments. Let me actually delete all of those. Delete those things, yes. And I'm not sure, can I do this? Or is there something locked on the scope? You see some stuff here. This is how I usually name my deployments so that I have one deployment per timestamp. We don't need to do that here. You can just build it up in PowerShell to have the timestamp here so you do not overwrite deployments all the time. So let me see. This worked out. It deleted and it still lies to me like always. And now, okay, I don't even know what that means. Executed, delete. Okay, let me do Command F5. Control F5, I mean. Is that still? Okay, it's still there. I don't know what's going on because he said he deleted 50 items. Could be that they are, I don't know what. Anyways, so our deployment is gone. So what I now will do, I will execute after I rename my module. I will now execute the deployment again. And let's check if now he is not doing this weird GUID stuff. And then you will probably understand why it's better on even modules to name it correctly. So let's go over, refresh this list, which is not giving us anything. Here it is. This is our new sample deployment. And this time we have resources and the resource group itself. Okay, so as you can see, if you call a module, what you actually do is you call a sub-deployment, a new deployment, a nested deployment inside of your deployment. This is what a module actually is, and you should name it as well so you can distinguish it if you have multiple from different deployments. Nice. So now back to my thing here. Let's go to the subscriptions. Yeah, and let's see the overview. Let's see the resource group. Let's go here. Let's refresh the page so you can focus on this, and nothing changed here. From that moment on, we are ready to go to the virtual network. Good. So let's hop over back to Bicep here. That's my module call. So I can now concentrate. I can close, deploy, and the other stuff. It works all the time. It's clear the screen so that you guys don't get too much distracted. I know I'm jumping a lot, but it is what it is. So let's start by doing it in a way that, let's say it's the most naive way to deploy a VNet. So let's start. So we want to deploy a VNet, which is a virtual network like we did it a second ago. And let's see what are the required parameters. So that was the wrong one. This is SCVMM. No thanks. So let's redo this. Virtual network, not this one, this one. So here's the provider, Microsoft Network, virtual network. Let's do this. And here are the required properties. So all you need to tell bicep in order to deploy a network, and let's do that, is this one. So let's build the name VNET dash, and then the same like we did on here, like the two lower. It's just the prefix that changes. Okay. And because we will probably need that a lot, this, let's call it suffix, I'm doing it a little bit different. What I'm telling is I'm doing a variable var suffix is this one. So I will probably need it a lot to put it in. So let's do the dash here as well. So no, maybe. So let's just use the suffix variable here. So I want to deploy just a VNet, and Bicep told me that the only required parameter to do so is the name. Okay, so let's do our deploy with whatif to see what will happen. And I'm not cutting this out so you can see how long it actually takes. So let's do the whatif, and he's actually complaining about the location not being set. We will fix that in a second. So he is now checking, is there a VNet in Azure? It should not be there in that resource group. It shouldn't be. Here it is. So he says, okay, I'm deploying the resource group. Yes, that's what he told you. And then he says, I need to create a new VNet. Looks good. So let's get rid of the last warning and tell it, hey, actually use the location you get passed in so the warnings disappear. So I usually, by the way, do it this way, that I always define a target scope in every bicep file. I always bring the params first, and then the variables. I always do the variables before any resources, so I collect the variables. The order of things in Bicep doesn't matter. So you could take this and move it down here, and it would still work. Because the Azure Resource Manager, which is then deploying this, and the Bicep compiler, transpiler, not compiler to be exact, will figure out the order of things here, because this needs the suffix, again, the same thing. This is step 2, and this is executed before, because this is referencing this, and he knows the order of things. But from a readability perspective, I want to have it all here. There are people saying, hey, you should leave the variable near to your resource. So if I have more resources coming before the VNet, hey, let's keep the suffix here. It's not going to be the way I do it. I just have a variable block, if you will, on the top of my file. So I see, okay, those are the variables. Anyways, a lot of talking. So now I have a VNet. And then with this one, let's deploy the VNet without whatif. So now it actually should deploy the VNet itself. So let's wait it out. And he says, again, there is an error. So that's exactly what I wanted, because this is a good example where the required macro here of this thing isn't working correctly. So basically what he says is no address, prefix, or pool provided. So it turns out he actually cannot deploy a VNet just by defining a name, which is not good, right? So that this script isn't working. One of the few things that I really dislike, params, I think. So what this, what is it? Properties, not params. Okay. So what it actually needs to have is an address space. So let's do it, as I said, the naive way. So the address space, I think, is it address space? Yeah, it's address space. And why is that? Let me think about that. Let's do it. 10. I'm just doing it and then explaining it. 10, 0, 0, 0. And let's do something very hefty. This one. And he says the property expected value of address space or null, but the rest is type. Okay, so it's address space an object. Yeah. No, that's what I was expecting. Oh. Okay, it's not coming. Good. So, few things to talk about right now. So, first of all, and again, I try to make a timeline so that those guys of you who know what the address prefix is and know what a CIDR notation is and so on can skip. I don't want to do that here because, as I said, it's kind of the beginner level VNet deployment. So what is this does this even mean? So let's go from inner to outer. First of all, what is this? So in order to understand that, I have a neat tool here locally installed. Let me hop over. And this is a Docker container running on my machine. So I can do this, and it's called IT Tools. I highly recommend this. I will paste in into the description the Docker command to actually execute this on your local Docker. And then what you can do, you have a bunch of cool tools here, which I really like, and you can search for CIDR, and he will give you the IP VNET subnet calculator. So here we go. So basically what you can do, you just take your CIDR notation here, and you paste it in, and it tells you what this means. So what this CIDR, I don't know, I call it CIDR. What this is, it's a way to explain how much IP addresses should match into something, should fit into something. So what the VNET needs to know is, well, how many addresses from what area of addresses should I be able to provide or to manage? Okay, so the 16 means the whole thing is 32-bit. Because it's like 0 to 255 on every element here. So it turns out to be 32-bit. And what you tell by the 16 here is the first 16 bits are fixed. So meaning the first available address is, where is it? Here, 10001. That's the first available address. And the last one, the last available address, where is that? Here, it's 10.0.255.254. So 255 is not available because this is a broadcasting address, and this is why this is here. So it's not available. You can give you can't give a resource this address. So that's why you left it, and it turns out to be 65,000 something addresses, which in Azure is not true. You have far less addresses than that, but we come to that. Anyways, so this means, okay, this is the range we are talking about. Usually you probably do something like that on VNETs, which are centrally managed, because it's a lot of IP addresses available. And so you might ask yourself, why is it that I can have 65,000 IPv4 VNET addresses assigned to that VNET? The reason being, because we are talking about a so-called class C VNET. So the 10. Whatever, 192.172. Whatever, those are addresses which you can easily assign, because no public IP address will ever be used in those ranges. Those are called Class C networks. And it's the same like you have on your private router on your local network. So your router at your home network is actually saying, let me make a drawing, because this gets confusing real quick. And I just recognize I have to do a very, very thorough timeline on my YouTube video. So what it actually says is, okay, listen, you have a network, a VNet. And at your home, what creates this VNet is actually your router. Usually, at least, if you're not into, so you have a router which says, okay, I'm the device which usually has a VNet antenna on it and whatnot, and this thing serves at actually one purpose, two purposes. It's also your firewall, but we're not talking about security here. So what it does is it's able to connect to the internet, which we should say here. This is the internet. And then it also needs to connect everything inside your VNet to each other. So, which means it's this way and that way. Let's say this. So the question now is how it is able, how is this thing able to decide if, let's say, you have a laptop. Oh yeah, great stuff. If you have a laptop, and let's say if you have a printer, and then you want to print from your laptop to your printer. So there is no direct cable usually between your laptop and your printer, but both are connected to the same router. Okay, so what happens is your laptop says, well, listen, I am, let's go here, and let's say, usually, where am I? Let's say, no, I need to learn this tool. 192.168.0 whatever 20. Let's say this is the IP address that your laptop has. Usually it gets it, by the way, from the router as soon as you connect it, and it keeps this IP address. And let's say this is 30. So now your computer wants to print here, and what it says is, it could be a DNS name, doesn't matter. It says, I want to print at this IP address. So who does it tell it this? It tells it the router. So because it sends out a package saying, I need to talk to this IP address, and the router now does a certain thing. He knows, and by the way, the router has an IP address as well. Usually, come on, the router has 192.168.0.1. So this is a router. So the only device your laptop is connected to is the router. And if you look into your local IP config, what you can see on the connection that you're talking to is here. This is not the one I have a lot of, because I have VMware. Here it is. I have a Fritzbox, and this Fritzbox is giving me the address 174, which is a preferred one. And then I got the DHCP and DNS server pointing to this address. So what this means is, this is my Fritzbox, right? This is also my default gateway. So all those three things are configured on my network to be at this IP address. So what it means is, whenever my local computer wants to know where, let's say, google.com is, it can only know that because its DNS server is my router. Then if my router gets a request from my computer to say, hey, who is google.com? He looks first in his own network here if he has some entry for google.com, which usually he does not have. So what then happens is he goes out to the internet here on this route and asks the DNS server of my internet provider to resolve that for him, and then it answers me. And by doing it, what I get back is an IP address of google.com, and then the next thing, my browser tells the router, hey, actually get me the page. So what the router understands, now he gets an IP address from Google, and he now decides, well, wait a second, this IP address is not in my range. It is, let's say, 8888, whatever. It's not a class C net, so I have to go out in order to get the content. On the other hand, if I tell my router, hey, I want to print to something which is in his network range and it's private, he knows instantly, I don't need to go there because I will resolve it here. And that means if you happen to have the same 192.168 whatever on your virtual network, it doesn't matter, it never will collide because my router will never go out and search for that IP address anywhere else. That's why this router acts as a gateway. And that's a very, very important concept in Azure as well. So there's a gateway, and it's this, what we do in Azure when we build a VNet, we actually build this whole thing. We actually deploy, if you will, we deploy a gateway. That's what the VNet in term could be called at. And in fact, every subnet, and we talk about that in a VNet, has its own gateway. That's one of the 5 addresses that you lose to Azure and you cannot give to resources. Anyways, I hope this is this was clear. I'm not sure. I just wanted to do all this circle in order for you to understand what we actually do. So what we told him here is, listen, this is a class C net, what I explained, a private one. Take 16 bits and fix them, the first 16 bits. So this never leaves this range, but you can happily have 65,000 IP addresses somewhere here. Then the next thing we need to talk about, why is this an array? It is an array because an Azure VNet gateway, the thing that you cannot see, it's just the VNet itself, could totally have two of those. Let's see, 0016. So you could tell the VNet, actually you have two address spaces. And you could do that on a router as well at home to tell him, I'm not sure if every router can do it, I think no, but good routers allow you to have the same thing and telling, actually I have two separate address ranges, which you should manage. But usually we only have one. Okay, and then this is the address space this VNet should take. So, as you've seen, by the way, the what-if deployment in Bicep did not fail when we checked it the first time. So this also confuses people, by the way. The what-if is not checking if your deployment is going to happen. It's just checking if what needs to change. Only if you deploy it, you will get an error or not. So let's do it again. Oh, maybe I messed it up because I didn't save. Let's see what's happening. I'm not even sure. If I deploy after I canceled one deployment, I probably get a bug saying there is already a deployment going on. Another concept that I should explain. So I executed this, then I canceled it, and then I right away started a new deployment. Let's see what happens. I'm not sure. Depending how long this took, usually it could come to a conflict because he says, well, there is actually a deployment running the same name, but it didn't happen. Okay, so he did it. Nice. Okay, let's look into Azure now to see what happened. Refresh this, and lo and behold, we have a VNet deployed. Now it works. So the only second mandatory parameter besides the name is the address space. So let's see. So here we have a VNet. This is how it looks. And now the address space is here. This is 10.0.0.0.16. Like we said, we have 0 subnets deployed. We talk about this concept in a second. The DNS server is provided by Azure because we didn't provide our own DNS server, which you usually do. And then we have it in the subscription. Everything is here. So good. And there's a bunch of stuff you could deploy there. And we're not talking about everything here, but at least about subnets. Okay, so let's talk about subnets. What's going on? So actually, a VNet by itself is not able to take in resources and to give resources IP address. So you cannot put anything into a VNet directly. Instead, what you need to do is you need to deploy at least one subnet. And this array tells you could be more than one subnet. Let's start with one subnet. And this is an object. And this object is giving you some parameters, ID, name, properties, and so on. So first of all, this is again where Bicep is kind of weird. On those objects, he gives you sometimes not, sometimes he does, an ID property, which you actually cannot define. The ID property turns out it's something which is generated during the deployment and then returned. But because the Bicep shares the whole information in this place, it seems like you could provide an ID. You can't. What you can provide is a name. So the name is now the first thing where people start to struggle, because usually, I'm a big fan of lowercase stuff. You should say something like, this is my test-VNet. I think it's not even possible to define a dash. I'm not sure, but we will see. And you need to define, again, an address prefix. And now this is the same as here. As you've seen, there was an address prefix. We ignore that. The point is, this address prefix is the same CIDR notation as here, but whatever you define here must fit into this space, okay? Or into those spaces. So whatever, if you have multiples deployed, that's okay. The prefix here need to be fit into one of those because we only have one here. So what does it mean? So it means this here is in theory, I think, possible. But this would mean, what this means is that the address space of this VNet is exactly as big as the complete address space for the subnet. It's exactly as big as the address space for my VNet, which means I can only have one VNet because it consumes all the available space of one subnet. Sorry, because this subnet down there will consume all the available space from the VNet. So this is usually not what you do. So what you actually do is you could say something like 32. So you put in a bigger number, meaning that you lock more bits from the beginning. And actually it means you have less space. So let's take this out and let's put it here, just the 32, which means now you have only, where is it available? Where is this? Am I not doing it? Network size is 1. So this 32 is far too big, too small. We talk about this in a second, but this would mean your first address is 10.0.0.0, the last one is 10.0.0.0, which is not fitting. That was not correct. We should have done this. Why? Because remember, when we do the 16, the first available address is this. So now when we do the 32, this available address is out of bound of the VNet. It's not possible. But if we do this, we tell it, well, actually, this is exactly one address big. You cannot do that in Azure. The smallest thing you could deploy in Azure as a subnet is a 29, which means a 29 gives you, in theory, 8 IP addresses available. In theory, this is not Azure, right? This is like a tool which is not aware of Azure. This is just a technical tool. But in Azure, every subnet has 5 IP addresses reserved for Azure, which means in Azure, this 29 subnet is the smallest you get because the 30 subnet is already 4 in theory, which is smaller than the 5 Azure needs for itself. So what's going on with 5? 29 means 8 addresses in total, and Azure will take, first of all, every subnet gets its own gateway on the address, whatever it is, on the first available address. So you have a gateway. The second one is, I think, DNS in Azure. There's a DNS service on the 2. There is some other stuff on 3 and 4. And then you have the broadcast address, which is the 5th one. Anyways, you can read it up. John Saville, by the way, a good guy on stuff like that. He had just a recent video about the Azure VNetting stuff and stuff. He talked about this very extensively. Anyways, 29 is the smallest range you can get in Azure. So 29 is a little bit small. Let's do a 24. So what is 24? 24 on the 1 means you have the 10.0.0.1 as the first address and then this one. And usually what I do, I say, well, is that possible? Yeah, the 0, this is my first space. So let's do that. And let's try if test-vnet is a valid name. I'm not sure, to be honest. Let's see. Let's execute this. And as you can see, VNet deployments are pretty quick, by the way. It's a resource which is so common that it's based on already predefined resources in Azure, which then are assigned to you. And if it have it already deployed, then it goes very quick. It's very important that it is that way. Microsoft did a good job here, actually, to speed up things and not have the VNet deployment to be a long-running task because you need it a lot. Oh, it's actually possible. Okay. Let's watch it up. Let's go to the subnets, and now you have a test-vnet. Okay, looks good. You could be happy and so on. Problem with that. There are some resources in Azure networking that if you deploy them for reasons I'm not fully aware of, but anyway, they can only be deployed in subnets which have a special name. One famous example is if you want to deploy your own gateway for the whole VNet to control the traffic, then gateways need to be deployed in a subnet named GatewaySubnet, without any dash, capital G, capital S. So you learn that the hard way. So that's why you usually say or I usually say, well, actually then test subnet. This is my name. And it conflicts a little bit with other conventions where I have lowercase with dashes. But anyways, I don't want this to be all over the place. So I give it the name test subnet. Let's see what happens. Because it's an array, it should redeploy all subnets if you do it this way. Always when it's an array, it's a kind of indicator that he deploys everything and overrides, which is not the default behavior, whatever you had before. So you have this test subnet with the 10.0.0.24, 251 available addresses in that. So let's compare that. 256 is the network size, minus 5 is 251. That's exactly what you see here. So here you can see the 5 reserved addresses of Azure. We're currently not talking about this stuff. We just have deployed a test subnet. And as long as you don't have assigned any devices to that, to the subnet, you can delete it, you can redeploy it. So you can play around here a little bit. And let's say, okay, let's do it differently. And let's say, well, actually, no. Actually, I want to be the first subnet, and let's make it small. It's this one. So let's talk about this subnet. It's a 29 subnet here. The last address is, the last available is 6. So the next available address is 7. It's 8, actually, not 7. 10.0.0.8.24. So, and let's call this the gateway subnet. So let's see what happens here. If we deploy this, now we have 2 subnets deployed, and it's not happening because I miscalculated. 0024, yeah, this is not happening. This is 24 is not, that's not why you do it. 24 is probably, let's say 1024. I will show you in a second. Should work. Let's see, we have this subnet and this subnet. Let's see if it works. Come on. Maybe it's already through. We can refresh it usually. Here we go. So now, look what happens. Interesting stuff. So here, now he says, okay, the test subnet is 10.0.1.0.24. So the first 3 bytes are frozen. So only the last can change. This leaves 251 options because we have 0 to 255 minus the 5 reserved. Okay, cool. This one is not giving us this because this word means something to Azure. So if you name it GatewaySubnet, like I did it, it means something to Azure. So he's not saying, oh, 29 means so and so many addresses. No, he's saying availability depending on dynamic use. So only the name GatewaySubnet means something to it. It's very important. That's why I did it this way. But anyways, we have a subnet now. Nice. Okay. So at this point in time, I must tell you, this is already bad, and I show you why now. So what we could do is we could say, well, actually, it might be that some other stuff which I need to deploy need to know where the test subnet is and need to reference it. So what I can simulate it, let's create an output and let's give it the following name, test subnet ID, which should be a string, and it should be from my VNET. I want to go to the properties and to the subnets. And now this is an array and I need to give him whatever this is. And from that thing, I'm interested in the ID. So let's do it and let's put in a 1 because it's 0 based. I'm not interested in this one. I'm interested in that one. So I have now an output. And in order to see the output, I need to go to my main module now, give it an output, test subnet ID, also a string, and this output is the output from my resources, which is called test subnet ID. So I pass back like I passed in parameters here. So if I want to see the output, you will see in a second, I need to pass it back. So let's deploy again. Let's see what happens. Come on. Here we go. So now, let me make a little bit more space here. So what my bicep now does, it tells me what did I pass in as parameters, and now I added an output of type string with that name, and here's the value. So what he actually says is there's a subscription with this ID. It has a resource group, correct, with this is the name of the resource group, and then I'm interested in the virtual network subnet, and this is the whole unique resource ID of my test subnet. Okay, fine. Let's go and switch I did 2 times Control X. That's 1 time. Let's switch it here. Let's see what happens now. I'm not sure. I never tested it out. What I did is I changed the order of things. So subnet 1, in theory, should be the gateway subnet now, because I think he's not ordering it by any range. And then, no, it's still the test subnet. Let me actually see if this is true. Let's delete those 2 things. Let's delete those 2 subnets, because it could be that he's not doing it because it already was deployed. Let's see. I'm sure I can make a trip, okay? So here we go. The subnets are gone. Let's redeploy everything. And if this is not going to work, I let it trip another way. Okay, here we go. And now my gateway subnet is coming out. So that's definitely not what I want to have. This is like, you know, this is like taking the offset, and this is not good at all, right? So this is not what we're going to have. Especially, let's assume we have another subnet, which is my another subnet, which now needs to be in the second here, because I cannot have 2 subnets with the same address space, right? So it's all about, we call that network topology, and you need to plan ahead really good. And I'm talking about those numbers in a second. But, you know, let's do another subnet, and then it gets even weirder. So now it all depends on when was what deployed, right? So you see the order of things now changed. Let's delete it again. And let's remove this, because he will not change the order if the subnet already exists. And then we will see what happens. So what I want you to understand is that this, first of all, this is what I see a lot in biceps, all of that. And second of all, you should understand that this is not good at all. Okay, this is not good. So we need to do better than that. So let's go. And now the test subnet is back again, because it just happens to be the second thing. But you know, it's not good. How can we do better? In order to do better, I want to overhaul the whole thing here. Okay, so let me zoom out a little bit, or maybe not. So now let's talk about how to do a better deployment. So the first thing I want to do is I want to take out the stuff here to actually control what this is in a better way. So what I'm doing is param, and I know this module resource will always deploy just 1 address prefix, but let's do it. Address prefix is a string which needs to come out from outside. So here we go. So I want to put it from outside. Main.bicep is not happy now. The address prefix for the VNET. Let's be good. Let's be a good guy, and let's pass in those properties completely. Let's give it this address prefix is passed in, and now let's define the address prefix in this file, which is far better. So let's go 10.0.0.0.16. That's my address prefix. Good. So from that moment on, I have a problem because now I don't know what this should be. Let's say somebody gives me another address prefix. How do I know which one to give to the gateway subnet, which one to the test, and another subnet? So what I do now is I talk about functions in Bicep. There's a function which we could use, var GatewaySubnet, that's first, equals prefix equals. And now there is this CIDR subnet notation, which says, okay, give me the network. The network is the CIDR value, which is just my address prefix. And then give me the offset, which is 29, and then give me the first of this. So that would result in exactly this one. So now I can do another one, test subnet prefix, whatever. And I do the same, but this time I'm saying give me a 24 subnet inside of this prefix, but give me the second, which is this. And then give me another subnet prefix, which is also a 25, but this third one. So now all I need to do is use this and use that. And now I'm good. But now I have another problem. Or actually, I don't have a problem. But, you know, if you think it through, it's kind of weird. Free variables, blah, blah, blah. It's kind of weird, right? So what we actually can do instead, we can create an array out of that. So what is it? So let's create a subnets array equals, it's an array of objects. So what we can say is, well, the first subnet is named GatewaySubnet. That's what we say. It's CIDR is 29 and the offset is 0, let's say. And let's say here we say the gateway subnet, this test subnet. Let's see, how do I do it? Okay, let's take the gateway out. Let's do this as subnets. Is test subnet. Actually, we only need strings. Let's say test subnet and another subnet. Okay, so fine. So now what we're going to do is we want to create var resolved subnets, and now comes another nice bicep feature, which is the map function. I think it's a map. The map function takes in an array, and then it takes in, it's a lambda function, and it takes in a lambda. And now what you do is you do, okay, I want you to map this, and I want you to bring in the S and the I. I think it's possible, S and the I. So S will be the subnet string, and I will be a number. So we can use that to actually say, well, what we need is, we need this thing, come out of it. We want to do, is that correct? Where is that? Subnet moves to this. This needs to be that. And is it a map thingy? Just let me see. This is going to be that, that, and that. This is nice. What is in our way? What do I have here? Moves to, think, yeah, there was one curly brace too much. So what this is now is I take this here and I tell it, take a 24 with the I plus 1. And here we say, well, actually, take the name of the thing, which is S. It's just strings, right? So take the name of that. So here we go. And then this is actually the workload subnets. And then I say the resolved subnets is union of. Take in another one, which is name is gateway subnet. Let's see if it works. And then this must be an array. And my workload subnets. So bear with me here for a second. So properties, address prefix, and this is my gateway subnet here, the 29. So let's see if this leads somewhere where we need to be. So here we go. Then I can delete this one. So what I can do now is I can, in principle, just pass in the resolved subnets here. So let's first see if this worked out. Let's delete all the subnets here real quick, and then I will try to explain what I did. Failed to delete any retrieval. Okay, this is also a bug in the Azure portal, by the way. So what it means is if you try to delete more than one subnet at once, he will always fail on the second one. So another error here. But he will do it. So I don't know what's going on here. By the way, this overlay has a lot of bugs. This do it on many operations overlay. But anyway, I'm not caring so much. Refresh, it's gone. So let's see what happens with my deployment. If it still works, and then we can talk about this whole mess and why it's maybe a good idea and maybe why not. But I think this is one important thing. Dum, dum, dum. So it succeeded. The result is the same as before. Look at this. This is my gateway subnet. Name is okay. Everything is okay. How did that even work? So let's talk about this. What did I do? So first of all, I created an array of strings. Okay, I'm just saying, okay, there is a gateway subnet, but actually I know that it's a fixed value. I always want this gateway subnet. This is a single thing where my gateway will reside in later. Let's see. So this thing is not part of my subnets list. I just say I want a test subnet and another subnet. Okay, cool. So now those are my workload subnets. In other words, subnets which are not gateways. They take in workload resources. Okay, nice. So what I'm telling him now, take this array of strings and then have a lambda function, which means for every element which you find here, create a new object with those properties, which means it's the name, it's just the string that we found. This is the first thing. It will be first this, then that. So the name will be whatever I told him. And then the prefix for this subnet will be calculated by using the address prefix of the VNET, searching for a 24-bit subnet inside this prefix with that offset. So what is this offset? So let's go back to the calculation. If we go to the 24 subnet, this is the first subnet that it can get, 10.0.0.1. So this is not available for us. Why is it not available? Because the gateway subnet that we defined already takes this space. So those spaces cannot overlap, okay? The subnets cannot overlap, it's forbidden. So, okay, I needed 24 because I want to deploy a lot of resources there, more than in a gateway. But this is taken. So I need to do the second 24, which is this one. This is the second available 24, which is not interfering with the first, which is the 29. Okay, maybe I should draw that again. Okay, so what it means is, can I have a new one? Probably. I can have a new Xcali draw. And can I remove this? Is it, by the way, removed from? Yeah, it is. Okay, interesting. So what I said is I have a VNET which is 10.0.0.0.16. So now inside of that VNet, I have a subnet, first subnet, which is my gateway, which is defined as 0029. In other words, what it means, it takes 10.0.0.1 to 10.0.0, I forgot, what was it, 29, 0.29 to 6. Actually 7, including the broadcast error. So, meaning those IP addresses are now taken on the complete VNet. Those two addresses belong to this subnet. Nice. So let's say I would say I need now a 24 subnet, which has far more addresses. This would mean this subnet tells this calculator tells us it's going to take up until 255. So meaning those are now overlapping. You can hopefully see that. This 8 addresses, 9 addresses, whatever. I cannot count. 1, 2, 3, 4, 5, 6, 7. It's 7. Idiot. Anyway, this 7 addresses are already taken and the 10.0.0.1 is doubled. So that's why I need to increase the number here and saying I need the second 24-bit, which goes to 1 and 1. This is what it does. So now this one is not overlapping with this one. But the next one, which is also a 24, must match into this because it will 2 and 2, which is not interfering again with anything else. You see the pattern? So that's what's going on. But this is what this thing does. It says, well, take the 24 and then do the I, which starts on 0 for test subnet, and 0 is already taken, so I need to increase it by 1. So this one gets 1, and this one gets 2. But if I add another one, a third subnet, I just do it this way, redeploy my thing, and it should easily create a third subnet, and all is good. So let's take a look. And now I have a third subnet, which got the 3/24. So nice. So I'm not even sure what happens if I mix order here. Is he able to do that? Is he switching the subnets? We will see in a second. Is third getting the 2? Is this going to be exchanged like, you know, whistling? Yeah, it does. Third now has a 2, another has a 3. So by just simply defining the order of things I want to have here, I can redeploy it at any time. Now, the last step is I actually need 4 subnets. I want to say then whatever is defined here, I want it to be 2 arrays. Those 2 arrays, this is an array, as you can see, because the map function returns a bunch of those objects, the bunch size determined by how many did I define here. We got this out of the way. So, and this function just says statically add in front of it always the gateway subnet. So that's it. So this is how I design my module. Nice work. So, and then it just, you can see how easily this is. The main work is in the preparation. Now, the last thing I could do, I could say, well, actually it would be great if the subnet could be defined. Let's say the subnets could be, subnets is a string array. And then I can say, well, actually get it as a parameter description. The names for all subnets which should take in resources, the gateway subnet will be deployed additionally, whatever. So now at this point in time, I can copy this parameter over here, pass it on. Subnets is subnets. And now the good thing is I can go here and define my subnets here. And I can give it just the same thing. I can say, and now maybe let's do a little bit better. And let's say all I want to do is my, what do we do? The VM subnet and the jump host subnet to have some more legit names. Let's do it again. What did I do? Let's deploy again. And now we have full control. And this module is very, very nicely reusable. I will show you that in a second, hopefully. Okay, let's lower this. He said, I'm succeeded. Let's refresh. And now we have a gateway subnet, we have a VM subnet, and a jump host subnet. All of that. And the only thing to control how this is generated is the param file, just here. That's it. Okay, so what if I want to now, and now it gets more and more complicated, what if I want to know what the VM subnet is? I want to reference the VM subnet ID. So I need to go to my resources and say VM subnet ID. So what offset is it actually? So this is now a new problem, right? Because now I don't know even here what gets passed in. How would I know which one to deploy? So what I could do is I could say, well, actually, if we have something which is called a VM subnet, so first of all, start the following. Let's give out the subnet as an array, an object array. Let's give that out to the caller. So this is like the subnets. Okay. So this guy now, the subnets guy can say, okay, the VM subnet ID is the following. Go to the subnets that are returned to the whole array. And now there is another bicep method which can help us out here. The thing we can use is we can use the filter method. The filter method says, okay, I take in an array and I can then use a predicate to resolve to one element of that array, and then I can give you that. Okay, so what do we have? So in order to understand what we need here, we actually need to map the subnets that we get, resources output subnets, using again the subnet and offset to the following. We will create an object out of that saying the index of the element is I and the subnet itself is S. And then what we will do is, let me see, this is the object closed here, comma, and then we will say N and I moves to, find me the subnet name equals VM subnet. I'm not sure if I need the, but anyways, give me the first element of that, and I think this needs to be another parenthesis. Let me look up my code that I had, and I'm not even sure if I need this. I think I can remove the map function. Let me remove the map function. Now let's do the filter again, and let's say the filter needs to be filter out where the subnet name S subnet name equals VM subnet. Is it working? Filter blah blah blah. That is the filter function, the first one, and now the ID. Well, let's see. This is not happy. Object and int. Yeah, that is why I mapped it before. So the problem with that is let me do the mapping. Subnet is S, and then subnet name. Let me copy out my filter function. Anyways, let me copy this out. And this is working, filter. And then this is going to be VM subnet, and he's not happy at all. Why is he not happy? Because he's not happy because this needs to be the name. And then this one is saying any. Why is that? Subnets is an object. Oh, because he does not know subnets is a string, which is wrong. Let me see. This is this, and in the main, I think this is the wrong one. It's just a problem that it is resources output subnets. So that works. Okay, after this whole confusion, let's try it out. What will be the output of the VM subnet ID? I know it's still a little bit strange because it has VM subnet as a fixed one here, but we can now see that the VM subnet ID is this. Take the ID to see if he actually gets the ID out, no matter at which position the subnet is located. So let's see. See this working? So here we go. This is a correct link to the VM subnet. And now it's a matter of copy paste to say, what is the jump host subnet? Jump host. Jump host. Jump subnet ID is jump host subnet. Here we go. And because it's always bad to repeat yourself, we can do a little bit better, even. So here we go. We have now the correct jump. No matter at which position we deployed the subnet, it will still work. So, but this is awkward looking. So as soon as we figured out this function, and you saw me struggle with that because I just had to map inside of filter, whatever, it's just trick, read it out. But I will give it a name, which is, let's say, do the same, resolve subnet by name bicep. This is my trick. I will copy in my function from the other one. So it's just a nice description. It has an export here, which means this thing, this func is now available from outside. This is a func, which means it's a method I can call now from outside. All I need to do in main is now I need to import this. Let's do it here. Import from this one. And now I can go back here and say, this is the function I want to have. And now it's simply saying, well, resolve the subnet by, where's my array of subnet? It's coming out of resources, outputs, subnets. And which one do I want? VM subnet. So I want to have this, and this is then from that, the IDE, I think. Oh, this is wrong. So here we go. And then the second one, it's just a matter of copy paste. Here we go, and then the jump host. The only weakness of the function is if you mistype this, you will get an error. But anyway, the import goes to the top after the target scope. That's what I do. So here we go, we have outputs. And then let's deploy again and see if it works. And we have a reusable function, which is called resolve subnet by name bicep. So I have a second one, which I just have a function which is reusable. Here we go, and it still works, no matter at which point the actual VNet is deployed. Great stuff. So with that now, what it means, we can go on to talk about, okay, what's actually going on. Let's see, resources. So we now have a VNet. And the next thing which should happen now is probably to deploy some resources to that. And because I'm now at this point, I'm thinking about doing this in another video and leave it for today because it gets far too long, the video. But we have some stuff accomplished. So we have a GatewaySubnet deployed, and we talked about that this thing is a special name. So GatewaySubnet, always be aware. We have a bunch of subnets deployed where we can put stuff in, and those subnets are actually automatically defined in size and stuff just by getting in an array of subnet names here. And then it will calculate everything using some bicep stuff. And as I said, I will share this source code with you. You can look it up. And it's using basically this method from bicep, which is calculating a subnet based on a CIDR VNET or space. It will return all generated subjects after generation. And then this function will use this user-defined function in bicep to return the actual ID, the unique reference. You will see next time in the next series why this is why this would be a good point. The only thing I'm now thinking is, you know what? Let's rename this and let's call it, this is only the VNet deployment, VNet bicep. Let's do the VNet here, the VNet there, and then let's call this the resources VNet. And let's say, okay, so this is now saying, next time I want to deploy, in the next series, I want to deploy VMs and stuff. And that is why I think it's better to deploy it this way, to say we split the resources into separate files. The first one is the VNet file, and this file later will be accompanied by a file, let's say VMs. The next thing we do on the next series part is we deploy a virtual machine, and it's 2 virtual machines, and this is a whole other area in bicep virtual machines. So let me summarize. This is a long video, right? 1.5 hours, if I see correctly. So you saw me struggle a little bit with syntax here and there. So 2 things are important. First of all, let me know in the comments if you really want to see more of this stuff, because this is like not high level as I sometimes do, like certain problems in bicep or .NET or whatever it is, or Azure. It's not what I'm doing here. This is like, do it correctly. What do I mean? We went from just showing to arbitrary type IP ranges, which is bad because you can mistype and stuff, and you cannot reuse this VNet to deploy another one. Oh, by the way, before I finish, let's do another thing. Guys, the coolest thing I didn't even show. Let's go to my parameters and say, actually, 192.168.0.0.16. I changed the scope. So what happens if I deploy this? So now I'm changing my scope completely. Still the same subnets to deploy. I only changed this one value. So let's see if it works. Could be that it's, yeah, it worked. So let's see what happened. Let's refresh this. And just like that, the whole address space was changed. So first of all, he changed the address space here. He changed it here without me calculating stuff or whatever. How easy is that? So think about reusability of your modules. I almost forgot to tell you about the coolest thing. I was so concentrated on the subnet. Never mind. So again, let's go back to 1.7, I don't know, 12 something. I'm not sure if this is, let's look it up. IPv4 plus C address range. So what is it telling? Private network on Wikipedia. So what do we have? We have a 24-bit on the 10.0.0. That's what we did. We have a 20-bit lock on 1.7. This is by the standard of the, what was it? Which standard is it? Is it telling us the standard of private network? I cannot see the standard number. anyways, so what we can do, we have 24 bits on 10.0.0.0. We have 16 bits on this one. So actually, the 10.0.0.0.16 was a bad idea. Was it? No, I can do 8. Oh, that's what I always mix it up. Guys, so this is, by definition, this network. Let's do it. If you use the 10.0 class CNet, so there are free, oh, there's RC, 1918. So there are free available defined class C, aka private networks ranges that you can use. So the first one has a 24-bit lock, which means actually it should be named an 8-bit lock if you ask me, because 8 bits are locked and 24 are available. Anyways, so let's do that. And it gives you 16 million potential IP addresses, minus a lot for Azure. Okay, so this is what you could do. Let's wait it out. Oh, it actually happened already. So let's see what happened. Refresh. So he's giving us this, but the available address space in total is this address space, 60 million something addresses. Okay, nice. So the next block available for you would be the 172.6, this one. So officially, this is the next block, but the 16, right? It's 16, it's 20-bit lock. No, it's not. It is the 12. Is it the 12? I think this is the one. Let me double check with my calculator. So this gives us 1 million and something. This is the correct one. This is the 12-bit. This is what this says. Mask bit is 12. So here we go. This address is allowed with 12 bits, even bigger. But if you're good with 16 bits, you could do this. Of course, you could do this with 16 bits. Also, it's okay to have 10.0 with 16 bits. How do you decide, by the way? This is going to be which one to select and how you do your topology planning and stuff like that. If you guys are interested in those videos, I will bring up stuff like VPN connectivity to your, I donated actually. So I will bring this up in another series part if you guys are interested in that. I'm not sure. All I'm saying is I want to show you, other than John Saville, which is having another focus on that, I want to show you the stuff like how should you do it in your environment to get repeatable, reliable results. And as you can see here, I'm now concentrated on those masks. I'm explaining you what are private masks. So you cannot do 192.168.0.0.8. By definition, you can do it. Azure will do it for you, but it's bad. Because it says the maximum lock on 192.168 is actually 16. You should not exceed the 16. So, and that's what they say here. And it's it gives you, what is that? The 16 means those two are okay. And here you see the range is going to 16 to 31. This is locked on 168, and this is giving 0 to here. This is why the address space is so big. You need to know stuff like that. Okay, so, but anyways, we've seen here how easy it is now to change this in your bicep. Let's go back to 10.0.0, 10.0.0.16 and redeploy it. And now you can easily tell that this VNet thingy is very much reusable. So I could deploy a second VNet, just copy this, give it another address prefix or the same, could be in another VNet this prefix, you shouldn't do that. But I could deploy 2 VNets in my subscription, and then I could peer the VNets and other stuff like that. We're not talking about this right now. Refresh, now we're back to 16. The subnets are aligned. Everything is great. So this is what I want to show you. So back to my last words, the second time I have last words. So as I said, if you're interested in more stuff, let me know. I'm not sure. I do not know, because I get not so much feedback. I do not know if you guys are in principle interested in my stuff, and usually there's a lot of guys who don't say anything. I have not much subscribers, not much views. Kind of the algorithm is putting me out of your way. So it would help probably if you share this or whatever, if you think it's useful, and let me know. I'm not trying to convince you to hit the subscribe button. Don't do it. Share it. Okay, share it if you think that this is something other people should know, especially people you are working with, right? So that they know if this is cool or not. Of course, only if you think it's cool. If not, also let me know. So thanks for sticking with me the whole time. I hope it was okay. Now I have to figure out my schedule and time thing on that and watch my whole thing again. Anyways, see you next time, hopefully, and I will come up with at least one more, which is a virtual machine deployment, which is a story for itself. But yeah, hopefully I see you next time. Have a nice one.